For question 4, we are going to look here at this data table to help us answer the following parts. The first question asks us to come up with an equation to determine the distance that Mike will travel after a certain number of hours. First, we need to determine what Mike's rate is. For that, I'm going to look here. This shows that Mike rides 26 miles in 4 hours. If I divide that out, I find that Mike is riding 6.5 miles in 1 hour. Now that I know his rate, I know that his equation will be D equals 6.5 times T, as I know that the rate will always show up being multiplied by the time. I determined that in part 3, question I. Question B asked us to sketch a graph of the equation, and I did that here. I determined the range of the hours by looking at Mike's data table, and his data shows from hours 0 to 6, and I went slightly beyond that. I determined the range for my distance by looking at his data table and saw that he traveled up to 39 miles, and I let my graph finish there. Question C is asking me to determine how I could find the distance that Mike travels in 7 hours and in 9.5 hours, using the table, using the graph, and then using the equation. Using the table, to find how far Mike travels in 7 hours, I would simply add 6.5 to 39, and that would get me 45.5 miles in 7 hours. To determine for 9 hours, I would continue adding on 6.5 until I reached 9 hours, and then go back and determine how far Mike rides in a half an hour. To do that, I would take 6.5, divide that by 2, which gets me 3.25 miles. I would add 3.25 miles onto how far he travels in 9 miles to get my final answer of how far Mike travels in 9.5 hours. This comes out to be 61.75 miles. On the graph, I would simply extend the line of Mike's distance till I've gotten to the 7-hour mark, trace that over to find the distance. Unfortunately, my graph does not go up that high for distance, so I'm unable to do that on the graph on my iPad. I would do the same thing for 9.5 hours. Unfortunately, my graph on the iPad does not go that far for hours or that far in distance. However, I would continue to extend that line until I've reached a line that equals 9.5 hours and follow that over to determine the distance. For the equation, all I simply have to do is plug in my hours of 7 and my hour of 9.5 into the t in my equation. So I would get d equals 6.5 times 7, which equals 45.5 miles. I would do the same thing for 9.5 hours, and that gets me an answer of being d equals 61.71 miles. Question D asks how we can find the number of hours it would take Mike to travel 100 miles and 237 miles using the table, the graph, and the equation. Using the table, I would continue to add on 6.5 miles until I reached 100 miles, and then I would continue to add on 1 hour until I reached an hour that lines up with 100 miles. I would do the same thing for 237, continuing to add on 6.5 until I reach 237 miles, and doing the same thing, adding on hours until I have reached the hour that lines up with 237. On my graph, again, I would extend this line until it has reached the point on a graph where the distance is of 100, and again when the distance is 237. I would then follow that distance to the line, bring it down to the hour, and use that to determine how long it would take Mike to travel 100 miles and 237 miles. Using the equation, I would take the 100 miles and divide that by Mike's rate, which is 6.5. After calculating that, that comes out to be roughly 15.4 hours. I would do the same thing with 237 miles. Divide that by the rate of 6.5 miles per hour. After calculating that, it comes out to be about 36.4 hours. Question E wants us to look at how we determined the answers for Part C and Part D, and lists advantages and possibly disadvantages to finding the answers using a table, a graph, and an equation. I believe that the disadvantage to using a table is that you may not reach 100 miles exactly on a certain hour. Then how can you determine the hour? You may not get an exact answer. The same thing with a graph. It's really hard to determine an exact answer using a graph when you may not line up with an exact hour or an exact distance. That's a huge disadvantage. Plus, with a graph, you're going to have to continue adding on to your axes to get to the numbers that you need to reach. The advantages of using an equation is that all I simply have to do is, to find distance, I just need to plug in the time. Or to find time, I simply need to take my distance divided by my rate. It's super easy and I will always get an exact answer. Question F asks me to compare the rate of Mike with Jose, Mario, and Melanie from the previous set of questions. Who rode the fastest? I can determine that Melanie rode the fastest because her rate of riding was 9 miles per hour, and that was the highest rate. How can I determine this from the table? All I simply have to do is look at hour 1 and how far each rider rode in 1 hour. By looking at this table and the table on the previous page, I can see that Melanie rode 9 miles, meaning that she rode the furthest, meaning she is riding the fastest. On the graph, I can determine this by the slope of the line. Here's my graph from the previous set of data. If I were to add Mike's data onto here, his line would be roughly here, between Jose and Mario. To determine who is riding the fastest using the graph, I simply have to look at the steepness of the line and can determine that Melanie's line is the steepest, therefore she is riding the fastest. For the equation, I can simply look at the constant that is located in front of t, and I can see that Melanie's equation has a 9 in front of t, meaning that she is riding the fastest.